Hello friends, my name is Ankit. I make informative videos on healthcare FHIR interoperability trends. I'm back with another video on FHIR Data Exchange Architecture. If you are new to my channel, welcome. If you regularly watch my videos, I would like to thank you for your patronage. Please like and subscribe to my channel for future updates. Uh, Now, coming back to today's topic, in today's vlog, we'll delve into the practical aspect of implementing fast healthcare interoperable resources in healthcare system. This session focuses mainly on data exchange methods, integration pattern, and real-world use cases that illustrate FHIR application. Now, what all are the data exchange methods? So one of the key data exchange method that we have been all hearing about is RESTful APIs. FHIR promotes RESTful representative state transfer principles, making it well suited for data exchange through RESTful APIs. Healthcare system can use HTTP methods, for example, get, put, post, delete. All these are the methods to interact with FHIR resources, making it accessible via standard web-based protocol. RESTful FHIR APIs are commonly used for real-time data retrieval, updates, and patient record access. This is one of the example of RESTful API uses. A user is submitting a request through a web-based application, which is transferred via API going along with the web service to the database. Now, keep in mind that behind the scene, we have OpenID Connect and OAuth-based authentication and authorization and patient match that is being performed before the information is returned by the database via the web layer using APIs back to the member or the beneficiary using the RESTful APIs. Now, there are different type of data exchange methods. One of the common method is messaging. Messaging-based data exchange involves the use of healthcare messaging standards such as HL7v2 and HL7 FHIR messaging to transmit FHIR resources between systems. Messaging is valuable for asynchronous communication, batch processing, and integration with legacy systems that rely on traditional healthcare messaging standards. This is one of the HL7v2 processing lab flow example. So in this particular scenario, the HL7v2 messages, it can be either stored in the internal staging or a cloud-based staging environment. The message is passed from HL7v2 into the HL7v2 JSON message. And then it is processed for further processing and then loaded into the healthcare data model for downstream uses by the laboratory and other system. Now there are different type of integration patterns. We have point to point, which was typically used in the hospitals with a monolithic EMR system. Then we moved on to hub and spoke model. So typically in most integrated hospitals with multiple systems. The next the improvement came in form of service-oriented architecture, typically in the regional solution or large hospitals with developmental teams. Uh, Finally, we moved towards hybrid, which was a combination of on-prem and cloud solution. And then the final path forward was the interoperability network, where the data can be exchanged using RESTful APIs between various systems in the standard common FHIR interoperable format. Now, talking about each of these, the integration pattern, point-to-point integration, it involves direct connection between healthcare system for data exchange. While it can be simple to implement, this approach can become unwieldy for the number of integrated system grows, resulting in complex maintenance and management. Hub and spoke integration uses a central hub or intermediary system to manage data exchange between multiple healthcare systems, which are spokes. This approach simplifies management, reduces complexity, and allows for more efficient data routing and transformation. Service-oriented architecture is a method of software development that uses software component called services to create business application. This is a common method used when we are talking about multiple regional or national level hospital or EMR system which are trying to exchange the information using a common service-oriented architecture. Hybrid cloud refers to a combination of different type of infrastructure, such as the on-prem solution with a combination of a cloud-based solution. It is an orchestration of an on-prem private cloud with third-party public cloud platform for bringing efficiency into the data storage as well as exchange of information. An interoperability network is the model that allows the transfer of data in FHIR interoperable format via RESTful APIs based on OpenID Connect 1.0 and OAuth 2.0 handshake for authentication and authorization. So these are some of the integration patterns. Of course, over the period of time, the focus is to move away from the monolithic architecture and to implement a smart on fire OpenID Connect and OAuth based solution where the interoperable data exchange can happen between EMR and various other downstream systems to ensure common data exchange as well as to improve access to the information, improving patient outcomes. Now, some of the real world scenario that we can talk about is the interoperable electronic health records, or also known as EHRs. FHIR is instrumental in creating interoperable EHR system that enable healthcare providers to access and share patient data seamlessly. Real world EHR implementation showcase how FHIR improves patient care coordination and clinical decision support. Another example is the health information exchanges or HIEs. Health information exchanges leverage FHIR to aggregate and share patient data among healthcare organizations. Case studies demonstrate how FHIR-enabled HIEs improve care coordination, reduce duplicative tests, and enhance public health reporting. Telemedicine and remote patient monitoring is also one of the real world example. The growth of telemedicine and remote patient monitoring is accelerated by FHIR. Use case illustrates how FHIR facilitates real-time data exchange between patients, providers, and telehealth platform, enhancing virtual care delivery. Internet of Things and wearable devices is a upcoming trend. FHIR supports for IoT and wearable device integration is showcased through examples of how patient-generated healthcare data from devices like smartwatches and remote monitoring tools can be seamlessly generated into EHRs and care workflows. Now, some of the best practices for the FHIR implementation are data standardization, security, testing, and validation. As part of data standardization, we have to ensure that data is standardized using FHIR resources and adheres to profile and extensions to maintain consistency. In terms of security, implementing strong authentication, authorization, and encryption mechanism is critical to protect patient data. Conducting thorough testing and validation of FHIR implementation to identify and address issues early is key to ensure that we keep the architecture secured and also protect the patient information. Now, some of the key challenges with the FHIR service-oriented architecture implementation are legacy system, data governance, and patient consent. We are still living in the 21st century where a lot of the involved organizations they still have implemented legacy system. Integrating FHIR with legacy healthcare system that uses older standards can be challenging and require bridging technologies. Data governance is also another issue. Establishing data governance policies and ensuring compliance with regulatory requirements can be complex. Patient consent, managing patient consent and data sharing preferences can be intricate, especially in the large healthcare ecosystem. So this is pretty much it about today's vlog. We'll meet next time with another topic related to the healthcare FHIR implementation. In the meantime, please feel free to reach out if in case you have any questions. I'll see you all next time. Take care and have a good night.